So hello students, I hope all of you will. So in my last lecture, I have discussed about the application of total internal reflection. I have discussed about the mirage, optical fiber, how optical fiber works, how mirage is formed. Okay. Now today I am going to discuss about the spherical refracting surface. Okay. So, in case of reflection, we have discussed about the spherical mirror. Now we will discuss about the spherical refracting surface. First of all, we see how a spherical refracting surface will be is made. Okay. Now, in case of mirror, you just take a hollow sphere and cut one slide. Then you will use this slice as a concave mirror or convex mirror by depend upon the painting. Okay. Now in spherical, same like this spherical refracting surface also we have to take one sphere, solid sphere. Okay. Now here we have to take a solid sphere, transparent solid sphere, plus sphere. Okay. Now, if we cut one slide from here, then it will be like this. Okay, it will be like this. Now, this is concave spherical surface. Okay, concave spherical surface. Understand? Suppose we again with this we have join another suppose glass plate or another piece of glass. So it will be concave spherical surface. That means convex spherical surface, not concave, convex spherical surface. Okay, if the glass plate, we will join the glass plate like this in this side. Okay, suppose we cut a slide like this way, or okay. That means like this. So remove this portion. Okay. Then this surface is act as a concave spherical surface. Okay. Concave spherical surface. Now same like the spherical mirror, there is some term related to the spherical refracting surface also. Just like the center of this spherical surface from which the spherical refracting surface is made is called known as center of curvature. Center of curvature. Okay? Center of curvature. And the midpoint of this refracting surface. This is the midpoint refracting surface. This midpoint is called as pole. Midpoint is known as pole. And the distance between pole and center of curvature, that means the radius of the sphere from which this spherical refracting surface is made. That radius divided by r is known as radius of curvature. Radius of curvature. Okay? And these are the different terms related to the spherical surface. One more term is there, the aperture, the length of this spherical refracting surface. This length, how much length? That length is called aperture. Okay, length is called aperture. Okay, so these are the different terms related to the spherical refracting surface. Okay. Now come to the sign convention. Cartesian sign convention. Okay. So just like the mirror, spherical mirror, the Cartesian sign convention for spherical refracting surface also same. Suppose this is the refracting surface. Suppose we consider one refracting surface. We place an object here. Suppose the image will be from suppose here. Let's consider. Okay. Let's consider. Image is from here. Okay. Now we will do infinity. So this is U. This is V. This is C, then it will be R. Okay. Now, just like the spherical mirror, the distance which is measured in the same direction of the incident ray are taken to be positive. That means this is the incident ray. If we take the measure, first thing is all the distance are measured from the pole. So reference pole should be taken as the pole of the spherical surface. So the distance which is measured along the same side of the incident ray will be taken as positive. So we have to take this measure distance from the pole. Here the object is, we have to measure the object distance in the opposite side of the incident ray, opposite direction of the incident ray. So object will be negative in this case. Okay, object distance will be negative. What will be the image distance? We have measured the image distance in the same direction of the incident ray, so it will be positive. And what about radius of curvature? So radius of curvature will be positive. Okay, that means in the positive, the direction, the measurement which is at the positive x direction are this positive direction, this side, or my right hand side. Okay. So positive x direction are taken to be positive, and the negative x direction are taken to be negative. Okay. And for image size, the sides which are along the positive y-axis, okay, that means upward direction, are taken to be positive, and in downward direction are taken to be negative. So these are that means, suppose this is one object, so we have to measure this object distance from this point, principal axis, and in upward direction. We have to take the measurement in upward direction from the principal axis. So this image size or object size will be positive. If the image is formed like this, suppose this is inverted, then we have to take the measurement in the negative y-axis, that means downward from the principal axis, okay, in this direction. Then this measurement will be taken as the negative. Okay, so these are the Cartesian sign convention using in spherical refracting surface, just like the spherical mirror. Okay, now come to the different type of lens. Okay. Now, all of you already got in class 10 about the lens. There are two types of lens, just like the spherical mirror, concave lens and convex lens. Okay. Now, how will convex lens will be prepared? So, if we take one sphere, we plug two slices, okay, of equal length. Then one is like this. Suppose one is like this. Okay, of the same size. Then we join these two slices. We join this two slices. The shape will be like this. Okay. So this lens is known as convex lens. Convex lens. Okay. So in case of lens, the convex lens is known as converging lens. That means it is converge all the incident ray to a point. Okay. Now suppose consider one parallel ray. You see in here. After reflection, it will converge to a point. After reflection, it will converge to a point, and that point is known as focus of this convex lens. Focus of this convex lens. It is different in case of it is vice versa. It is vice versa of the spherical mirror. In spherical mirror, convex mirror will be act as a diverging mirror, but in case of lens, convex lens will be act as a converging lens. Okay, and the ray which are parallel to principal axis is the principal axis. After reflection, it will meet at a point. That point is known as focus. Okay, that point is known as focus. And this point, okay, center is called optical center. The center of these two lenses is called optical center. Now, okay. Now come to the concave lens. Now we join these two lenses. We plug this card to slide like this. Suppose. Okay. And we will join this together. It will shape like this. So this lens is called concave lens. This lens is called concave lens. Why concave? It is caveless structure. So this lens is called concave lens. So at the middle point is known as optical center. Optical center. And this lens is known as diverging lens. That means after reflection, it will diverge, and it will appear to come from the backside of the mirror. It will appear to come from the backside of the mirror. Okay, so these are the two types of lens. So just go through this. So the register means this here. So today I will just teach up to this. So let's go all these lectures and okay. Thank you.